Hello everyone, this is Mr. Teen Tutor, and today we will be talking about the chain rule from calculus. The chain rule is used when you are differentiating a function. And here are two ways of showing the chain rule. The first one here, dy dx, which is obviously the derivative of a function, is equal to dy du times du dx, and as you can see, the du's cancel out. And here's the second method. We say that f of x equals g of h of x. And then we say that the derivative of f of x is equal to g prime of h of x. So we're differentiating the outside function, but with respect to the inside function, times then the derivative of the inside function. So obviously with chain rule, you're dealing with composite functions, which means that you have an outside function, in this case it's g, and the inside function, which is h of x. So let's work through this example problem right here, where you will be able to see these two ways of chain rule at play. So y equals sine of x squared. Now there are two functions at play here. We have the sine function, and now we also have the x squared function. So let's break this down. We're going to say that u equal x squared. And remember that x squared is the inside function. In which case then, if we know that u equals x squared, that means then we can rewrite this as y equals sine of u. Now let's differentiate each function here. So in this case here, we are going to be differentiating x with respect to u, which means that the notation is going to be du dx equals 2x, and that is derived from the power rule. Now let's look at this one right here. We are going to differentiate u with respect to y, which means that the notation here is going to be dy du, and that's going to equal, first off here now we have some functions here at play, so we have the sine of u, so let's differentiate the sine component first, because this is essentially our g. So we have cosine of u, and remember it's with respect to u, so the u is going to stay there, that's not going to change, times u prime, which in this case then will be du dx. And this is according to this definition of chain rule right here. So now let's substitute some things in. We know that u is x squared, and we know that du dx is 2x. So the answer to this problem is going to be cosine of x squared times 2x. So that is the derivative of the sine of x squared. It's 2x times the cosine of x squared. Remember, the outside function is the sine, and so we differentiated that with respect to the x squared. So it's cosine x squared times the derivative of x squared, which is 2x. Now keep in mind that when it comes to differentiating a function, you're actually applying chain rule every single time. So in this case here, obviously you see it. It's very explicit. But for others, it's implicit. And here's an example. Let's just take the function y equals sine x. Now in your calculus textbook, it says automatically that the derivative of sine x is cosine of x. But in this case right here, you're actually also using chain rule. Here's why. If we look at this one right here, we see that there are two functions at play. Once again, you have the sine function, and then you have x. So if you think about it, when we go through this definition right here, we take the derivative of the sine part with respect to the x, so it's cosine of x, times the derivative of the inside function, which is x. And as you all know, the derivative of x is 1. So technically, when you write out the derivative of sine x, it is equal to cosine x times 1. But obviously, anything times 1 is itself. So it is unnecessary then to write times 1. But this is essentially what you're doing. you're taking the derivative of the outside function, which is sine x, and then you're taking the derivative of the inside function. So this is technically how the derivative of sine x should be written. Now let's go through another example. I'm going to erase all this. Okay, so let's say our function is now y equals x cubed plus 2x all raised to the 5th power. Now this is a different way of showing the chain rule. So in this case, we have x cubed plus 2x, but then we have this raised to the 5th power. So let's let u essentially equal this. So in this case, if you look right here, you should think power rule because you have something raised to the 5th power. So how are we going to find this person's derivative? Well, or function's derivative? Let's start with the power rule. So we have this 5 out here. So now we're going to kick the 5 out in front and reduce this by 1. So then that's going to be 4, but this is going to stay the same. So we have 5 times x cubed plus 2x, all raised to the 4th power. Now we have taken care of the outside function, but now we need to look at this inside function. So this is going to be times the quantity 3x squared plus 2. And if you want, you can combine like terms here. You can multiply some things out. So in which case then with the 5 and this, we would have 15x squared plus 10 times the quantity then x cubed plus 2x raised to the 4th power. Now if you want, you can expand this, but normally calculus teachers will be fine with this type of notation right here. It's fine if you leave it like this. So here you go. This is your answer for this function's derivative. So once again, this is the inside function. The outside function is this being raised to the 5th power. So we use power rule by putting the 5 out in front here and then reducing this by 1 like normal power rule. And then we look at the inside function once the outside function has been taken care of, and we get 3x squared plus 2. And then once again, we just multiplied these two terms together here, and we left this as it is. So I hope you had fun with chain rule. Chain rule is a very important concept as you continue your endeavors in calculus. Chain rule will obviously come back when it comes to differentiation. So make sure you understand chain rule well, and I hope you had fun learning this concept.